Hello, and welcome to the CCNA Routing and Switching course offered by SimplyLearn. The previous lesson focused on an introduction to Open Shortest Path First, OSPF. This lesson focuses on Advanced OSPF. Let us begin with the objectives of this lesson in the next slide. By the end of this lesson, you will be able to explain the OSPF metric, describe the different link states, explain the concept of multi-access networks. Let us discuss the OSPF metric. The Cisco implementation of the Open Shortest Path First routing protocol uses the cumulative bandwidth of a route as cost. By default, cost for a single router interface or link is calculated as 10 to the 8th power divided by the bandwidth on the interface. Therefore, default costs are based on the interface type and speed. Take a moment to study the default link costs in the table on the slide. We will continue our discussion on OSPF metric in the next slide. An interface cost can be manually configured. Take a moment to study the configuration in the slide. Note, the cost cannot be set to 0. Now, let us discuss link states, also called neighbor states. Link states are the states that an OSPF router passes through or remains in as it becomes operational. Before a router participates in the OSPF process, it is considered down. Once it is enabled, the router sends a hello packet to its neighbor. The attempt state occurs only when the neighbor is statically configured and in a non-broadcast multi-access NBMA network. An interface is in the attempt state after it has sent a hello, but before it has received a hello from its neighbor. In the init state, a router has heard a hello packet from its neighbor and sends a unicast reply. The interface remains in this state if hello time does not match. The two-way state occurs when router has seen its own router ID in the hello packet from the neighbor and all neighbor requirements are met. The neighbor is added to the neighbor table and bidirectional communication is established between the routers. Designated router backup designated router, DR/BDR, election takes place in this state. Sequence numbers are negotiated during XStart, if applicable. If maximum transmission unit, MTU, does not match, the link will be stuck in this state. The routers send out database descriptions, DBDs, in the exchange state. In the loading state, link state requests, LSRs, are sent to neighbors to request more recent link state advertisements, LSAs. Link state updates, LSUs, are sent in response to the LSRs. Finally, in the full state, OSPF neighbors are fully adjacent. All the routers in the area should have identical link state databases, LSDBs, for that area. In many types of networks, routers reach the full state. However, this causes problems in multi-access networks. Let us discuss this in the next slide. Multi-access networks occur, for example, when multiple routers are connected to one switch. Each of the router interfaces connected to the switch is in the same subnet. Multi-access networks may require too many connections and massive routing overhead for OSPF to function efficiently. Take some time to look at the numbers in the slide. How do we solve this problem? Let us discuss designated router, backup designated router. A designated router, DR, and backup designated router, BDR, are elected to handle the routing traffic centrally and to avoid burdening a multi-access segment with heavy OSPF traffic. A DR and BDR are elected for each multi-access segment. The DR is the router with the highest OSPF interface priority. The BDR is the router with the second highest OSPF interface priority. If OSPF interface priorities are equal, the highest router ID is used to break the tie. The DR/BDR election occurs as soon as the first router with an OSPF-enabled interface is active on the multi-access link. The first router to boot is elected DR if defaults are taken. This is not a desirable outcome. The DR should be a router that has more processing power and higher bandwidth interfaces if possible. The election of DR and BDR can be influenced by configuring the interface priority. Let us move on to the quiz questions to check your understanding of the topics covered in this lesson.